talk about the inverse trig function, specifically integration. And so if you notice, there are 3 integration rules that you need to familiarize yourself with. Once again, you don't necessarily need to memorize them so much as just be familiar with the 3. The first one is arc sine. A refers to a number. Okay, so u is a variable, a is a number. So when it says like du over the square root of a squared minus u squared, that's a number squared minus a variable squared. Okay, same thing on number 2. When it says du over a squared plus u squared, that's a number squared plus a variable squared. Okay, and so anyway, we're just going to jump right in with examples. And we have this one as our first one. So if we look at this, I see I've got dx on the top. That could be similar to the number 1. And in the denominator, I have a square root, and I have a number minus a variable. Okay, so which of those does it look like it fits?
1.
Which would be?
Du over square root.
Right, so it's arc sine, right? The integral of it is arc sine. So basically what we're saying is that this is an a squared. So a in this case is 2. U in this case is? X. So what's du if u is x? 1. So that in fact fits because it's like saying you've got a 1 up there. And so in this problem, the integral of that comes out to be arc sine of u over a, which in this case will be x over 2, plus c. Biggest thing on these problems is recognizing which one it fits. Okay. Questions? Let's look at another one. Okay.
Clearly number 2.
So clearly number 2 because it is no square root. So let's go ahead and figure out what we have here. What is a going to be?
2.
No.
1. 6.
Root 2.
Root 2.
Root 2 because when you square it you get 2, right? It's like the square root of that number. U is
3.
3x. So du is
3.
3. So I need a 3 in and a 1/3 out. Okay, so first of all, I've got a 1/3 in my answer. And then the integral that this one fits is arctangent, which they tell you is 1 over a arctan of what?
U is 3x over root 2.
3x over root 2 plus c. So what you need to do before you give your answers, you need to combine the first 2. And so to combine the first 2, I will let you have the root in the denominator. 3 root 2 arctan 3x over root 2 plus c.
We've graduated, guys. We're allowed to do that now.
Questions? Let's move to number 4.
That looks like 18.
3.
That's 18.
Okay. It looks like the arcsecant one. So we need to identify what is u?
X.
Close.
2x.
2x.
Yeah. I suck.
What is a?
3.
3. What is du?
2.
2. So really, if I look, what I need is I need a u on the bottom times the square root of u squared minus a squared. So really what I need to do is add a 2 here, okay, because it's got to be u. So far so good. This has to be u. Now, oops, in order for me to solve the problem, I've got to have a du of 2 as well. So if you notice, really, what have I added in the problem?
2.
I've added the number 1. I've added nothing because I've added a 2 here and a 2 here. So I don't need to adjust anything outside. Okay? And so the integration rule is just 1 over a, so in this case 1 over 3 arc secant of what?
Absolute value of 2x
Absolute value of 2x,
over
3 plus c. And there you go. So before you go making a lot of changes in the problem, make sure that it doesn't like cancel out like that one did. Okay? Alrighty. Here we go. So let's go ahead and look at this one. This one's a little different. Okay. Which one do you think it fits?
Is it 1?
Let's just start. What do we think e to the 2x is?
U.
Maybe u. So what would u be?
2x.
2e.
No, U is e to 2x.
E to the x. A is 1. Remember, it's u squared. Okay? So the thing is, if I have e to the x and I square it,
E2x.
I get e to the 2x. If you have e to the 2x and square it, you're going to get e to the 4x. Okay? Alrighty, so I've got a u squared minus an a squared, so it looks real similar to arc secant, even though it doesn't have a u outside. So what we're going to have to do is we're going to have to manipulate it around a little bit. What does du equal?
E to the x.
E to the
E to the x times dx.
Well, we're going to have EX on the outside and on top, so they cancel, don't they?
So let's think about things.
We can put 1 over e to the x. Yeah.
So really, I know that dx will equal du over e to the x. Right? So let's do some changes here in my original problem. In place of dx, I'm now going to put du over e to the x. Okay. In the denominator, I've got the square root of e to the x quantity squared minus 1. So what have I taught you when you have more than one denominator? Combine them. So when we combine them, we end up having du over e to the x times e to the x quantity squared minus 1. Which really comes out to be du over, what is symbolized by e to the x?
U.
U. And then I've got the square root of
U
squared minus a squared. So that clearly fits the arcsecant one.
Yeah.
So I know the arcsecant one is 1 over a. So in this case, 1 over 1, which is just 1. Arcsecant, so you could put 1 if you want to put that. The absolute value of u, so what will that be?
E to the x.
The absolute value of e to the x over 1
Plus c.
plus c. So just absolute value of e to the x. Now, is that one of those that you're going to have to worry about solving a lot? No. But that is one that you're going to have to solve at least one.
Some pairs.
Yep. All right, what we're going to do is I'm actually going to leave 2 problems for tomorrow. And I'm going to give you the rest of the time to get started on your assignment. Here's your assignment, page 385, 1 through 17, the odds. 21, 23, 31, and 32. Now real quick, on the 1 through 17, the odds, you might be able to use an old way. So don't automatically assume